Chlorine will be present in transportation containers and at chlorine production, storage, repacking, and consumer facilities. Due to the properties of chlorine, most likely the only form of chlorine that a responder will encounter during a release is a gas. Exposure to liquid chlorine will be unlikely unless it occurs at the exact release point. The most common types of chlorine releases are from minor valve leaks that are easily mitigated and have minimal dispersion and ecological effects. For more significant releases, there are three types of releases: instantaneous, continuous, and intermittent. An instantaneous release is characterized by the release of chlorine into the atmosphere in a relatively short period of time, like a catastrophic container failure, such as a significant chlorine breach due to a train derailment. This type of release will result in a gas cloud that moves across the downwind range while increasing in size but decreasing in concentration. The concentration of chlorine monitored at any given point downwind will vary over time, depending on a number of factors. A continuous release is characterized by the release of chlorine to the atmosphere over a longer period of time, like a valve failure, rupture, or process fitting failure. This type of release will result in a continuous plume that reaches an equilibrium size and concentration gradient. The concentration of chlorine monitored downwind from the source will be relatively constant for the duration of the release. An intermittent release is characterized by the release of chlorine to the atmosphere for an unpredictable amount of time or frequency. The resulting clouds will be dependent on the length and cycle time of the overall release. One example of this type of release is a pressure relief device cycling due to temperature or volume change. The area affected by a chlorine release and the duration of the exposure are dependent upon several factors: the rate of the release, the duration of the release, the height of the release point. Chlorine is heavier than air and will settle into low areas. The current weather conditions, and the form of chlorine released, as liquid chlorine will increase in volume by 460 times as it becomes a gas. These combined factors are difficult to evaluate in an emergency situation. Chlorine concentrations downwind can vary from barely detectable traces to lethal levels. While the responder most likely will encounter chlorine as a gas, emergency plans should take into account the possibility of the release of liquid chlorine. The location of the leak on the container will determine whether liquid or gas will be released to the atmosphere. If liquid chlorine is released from a small puncture or hole, it will most likely instantaneously become a gas. When pressurized liquid or gas is released from a container, the temperature and pressure inside will decrease and in turn will reduce the release rate. This phenomenon of decreased temperature is due to the changing pressure condition of a breached chlorine vessel. The chlorine in a cylinder, ton container, tank car, or cargo tank is a liquefied gas under pressure. The temperature of that liquefied gas is cool, but not so cold that the exterior of the container would be cold to the touch. At higher pressures, liquids boil at higher temperatures. At lower pressures, liquids boil at lower temperatures. This is why water boils at lower temperatures at higher elevations above sea level. The atmospheric pressure is lower, so the boiling point is lower. When a chlorine container is punctured, or a valve or pressure relief device is broken off, allowing the chlorine to release, at first the chlorine will escape rapidly. As the chlorine is released, the container that was under pressure will now equalize in pressure with the atmosphere. Once the liquid level drains below the puncture point, auto-refrigeration takes place. Auto-refrigeration is the result of chlorine quickly escaping from the container, which causes the chlorine to cool down below its boiling point at the new lower pressure condition. It becomes colder because it is no longer under pressure from being in an enclosed container. Because the chlorine remaining in the container is so cold, a visible frost layer will form on the outside of the container at the liquid line, which is typically the level of the puncture. When this occurs, the rate of release will significantly decrease, although there still is a considerable amount of liquid chlorine remaining in the container. However, Any heat source, like water, or agitation, like moving the container to a secure location, can cause the remaining liquid chlorine to vaporize and allow more vapor chlorine to escape. Escaping liquid chlorine may collect in a pool and may actually form a running stream. Liquid chlorine, upon contact with any heat source, like the air, ground, or water, will boil. Typically, the rate that the liquid becomes a gas will be relatively high initially and may decrease as the heat source surrounding the chlorine is cooled. Since water in bulk, as used to fight fires for example, provides a vast heat source for evaporating liquid chlorine, any liquid chlorine falling into water should be assumed to react. For this reason, water should be prevented from coming into contact with a pool of liquid chlorine and should be prevented from flowing into water drains. Also, attempts to knock down a chlorine gas cloud with water should not be made. Liquid chlorine will react with any moisture present to form hydrochloric acid. Chlorine causes bleached spots on leafy plants because it reacts with the chlorophyll in leaves. Mature leaves are the most susceptible. Usually the plant itself is not destroyed, but yield or growth rate may be retarded. Chlorine's effect on animal life is similar to exposure consequences in humans. The lowest concentration of chlorine in air which has been reported to cause death in animals or humans is listed as 500 parts per million for a duration of 5 minutes. Exposure to lower concentrations for longer durations could also be lethal. The U.S. EPA has issued acute exposure guidelines for several substances, including chlorine. First responders should use all their senses when approaching an incident. Be alert to signs around you as indications of high chlorine concentrations. Chlorine is only slightly soluble in water. Aquatic life is fragile, and many forms would be adversely affected by chlorine in concentrations well below 1/10 of 1 part per million. Because of this, chlorine is listed as a marine pollutant by DOT. Chlorine does not accumulate in the food chain and is not considered a threat in this regard.